It's now time to present the grand prize winners in this year's International PM Design Competition. These are the parts that more than any other exemplify the potential that is within PM. No matter how demanding or highly visible the application, no matter how entrenched the competing technology, these parts met the challenge with creativity and flawless execution. In so doing, they continue to redefine what is possible with PM. Ladies and gentlemen, here are this year's grand prize winners. Borg-Warner Powdered Metals Inc. and its customer Borg-Warner Transmission Systems won the grand prize in the Ferris category for input and third position outer races used in GM's 4T65E transmission. The transmission can operate with several GM engines: 2.5 liter, 3 liter, 3.1 liter, 3.4 liter, 3.8 liter, and the supercharged 3.8 liter used in mid-size sport utility vehicles and sport vans. The other engines operate in several GM models, including Buick Rendezvous, Lucerne, LaCrosse, Chevrolet Monte Carlo, Impala, and Upland, Pontiac Grand Prix, and Saturn Relay. The outer races carry torque when relative rotation occurs in one direction, and in freewheel position when relative rotation occurs in the other direction. The parts are formed via an innovative tooling system and are selectively densified on the surface of the pocket formed to eliminate high wear encountered by the assembly in a freewheel condition. The races are heat-treated using a customized process to meet stringent strength and fatigue life specifications while minimizing part distortion. The inside diameter of both parts has 6 pocket forms that contain locking pawl and spring elements during operation. The input position outer race has a unique wave form on its outer diameter that adds complexity. The third position outer race's skirt is split into 4 quarter circle arcs, the entire length of the skirt. The parts have an ultimate heat-treated tensile strength of 131,000 psi and an impact energy of 12 foot-pounds and 32 HRC minimum apparent hardness. The races are the first production release of a patented Paul clutch design that replaces a Sprag clutch. PM provided a 20% cost savings over forged outer races. The parts are produced at a rate of 5,000 units per day for each race, or 1.375 million annually. This complex 316 stainless steel support cover won the grand prize in the stainless steel category. It is made by Webster Hoff Corporation and used in a military application that, for security purposes, was not disclosed. The cover is made to a net shape, with deburring the only secondary operation. It has a density of 6.5 grams per cubic centimeter, an ultimate tensile strength of 41,000 psi, a yield strength of 34,000 psi, and a 59 HRB hardness. During compaction, 2 heights and the weight of the part are measured every hour for statistical process control. The heights maintain a CPK of 1.33, and the weight is held within 3%, with a CPK of less than 1.0. The flatness and slot width are held at 5/1000ths of an inch. This highly complex electrical connector used in a plug and adapter won the grand prize in the injection molded category. The part is made by Advanced Materials Technologies Pte. Limited for Ubic Pte. Limited in Singapore. The unique part is made from copper powder to a density of 8.8 grams per cubic centimeter. It has an ultimate tensile strength of 36,000 psi and a yield strength of 8,700 psi and an elongation of 45%. The electrical plug and adapter that contains the MIM copper connectors is a new product used in the electrical appliance industry. The plug is ergonomically designed to make direct contact with the power track. The cover of the plug is made of polycarbonate. The plug can be engaged anywhere along the power track. The electrical adapter with the MIM copper connectors allows users to continue to use their existing 3-pin plugs to engage the power track. The MIM copper has better electrical performance compared to brass. Using a MIM copper part replaced processes such as stamping, turning, machining, and press fitting, offering the customer a cost savings of more than 20%. Sinterstahl Fusen GmbH won the Overseas Grand Prize for a camshaft sprocket used in a 4.0-liter V6 engine made for its customer, BorgWarner Engine Group Morse Tech Europe SRL. The part is made using an innovative tooling design with 3 lower and 2 upper punches. It has a density of 7.0 grams per cubic centimeter, a tensile strength of 119,000 psi, a yield strength of 99,000 psi, and a transverse rupture strength of 206,000 psi. The material is an iron-carbon molybdenum-chromium composition and is the first known application of a chromium-based sinter-hardened material for a camshaft drive. PM offered a cost savings of more than 10%. Burgess Norton Manufacturing Company won the grand prize for this three-wheel steering system axle assembly containing 16 PM parts used in a snowblower. The assembly consists of a stamped steel frame, bronze and plastic bearings, and a wrought steel axle, which functions as an on-demand differential traction control system. It is operator-controlled and activated manually with a hand lever mounted on the handlebars of the machine. The PM parts range from single-level parts with fixed features on punch faces and core rods to intricate multi-level parts with complex die geometry, core rods, multiple transfer punches, and fixed levels needed to form unique design features. The 32-tooth sprocket has 7 lower core rods that form the main bore and 6 fastener holes. The clutch pawl is produced to a net-shaped peripheral geometry that is not practical or economical with other manufacturing or material processes. All parts are formed close to net shape. Secondary operations are limited to vibratory deburring and honing. The clutch pawl is sinter-hardened, which allows oil impregnation. Because the sinter-hardened material is quenched in atmosphere rather than in the liquid medium, the porosity can be filled with liquid lubricants. PM provided a cost savings of at least 50% over parts made from machine castings and wrought materials. Annual volumes of 25,000 to 30,000 assemblies include the production of more than 400,000 PM parts. There you have them, ladies and gentlemen, the grand prize winners in the 2005 International PM Design Competition. Please join with us in welcoming them to the stage as we invite them to receive their award.